Alright, welcome. In this video we're going to be doing some linear inequality examples. And the first one's y is less than 4. So we're going to just give ourselves a little xy plane. And we know that the line y equals 4 is the set of all points where y is equal to 4. So I'm going to just mark off where I think 4 is. And so if it was going to be y equals 4, it would be a horizontal line. Since it's y is less than 4, we know we're going to have a dotted line. So let's give one of these. And since it's less, I'm going to shade in the area where y is less, underneath. And that's all. Okay, the second one is 3x is less than y. And, you know, I like to write these as y is less than or y is greater than. So I'm just going to switch it around and say y is greater than 3x, right? Still, y is the one that's bigger. Okay, and so if I was going to sketch that, I know what y equals 3x looks like. That would be a line with slope 3 going through the origin. But since this is greater than, I know it's going to need to be a dotted line. And since y is greater, I'm going to start up here. Okay, look for the y-axis. Where is y bigger? And then we're going to shade on that side. Okay. The next one's 2x minus 3y is less than or equal to 6. And, you know, I mean, I would say if this was a line and we were trying to graph the line, I'd just say find the x and y intercepts, plot those, connect them, and you've got a line. But for this one, you know, especially with that negative 3 attached to the y, it's going to affect the direction of the inequality. So I think I'm going to just solve for y. And so I'm going to start by subtracting 2x from both sides. And I'll have negative 3y is less than or equal to negative 2x plus 6. And then I'm going to divide both sides by negative 3, which is going to switch around the direction of my inequality. But when I divide by negative 3 and I divide everything by negative 3, I'll have y is greater than or equal to positive 2/3 x plus 6 divided by negative 3 is going to be minus 2. And I can do that. I know because it's got a negative y-intercept, I don't need so much of the places where y is positive. Since it's greater than or equal to, it's going to be a solid line. 2/3 is not a very steep slope, so maybe I'll just draw it like that. And what was I going to say? Okay, yeah, that's going to be negative 2 right here. And then I can figure out what that's going to be if I needed to. Say I was, you know, trying to graph this accurately on a grid. I would say this is going to be, well, the x-coordinate is going to be where y equals 0. And that would be 2x equals 6 and x equals 3. Maybe you could just tell that from the 2/3 slope. I don't know, I needed to be sure. Okay, number 4 is kind of like that other one where I'm going to just kind of switch it around so that y is less than or equal to negative 5x plus 2. Right, still negative 5x plus 2 is the bigger one, so it's the same statement. And I'll draw my axes, and okay, so since it's less than or equal to, it'll be a solid line. Negative 5 is a really steep negative slope, so maybe I'll draw it like that. Okay, and if y is less than or equal to, I'm realizing, hold on, yeah, I didn't actually shade over there. That's terrible. Pardon me. So since y is greater than or equal to, I'm going to need to shade up here, right? That was pretty bad. Okay, but it's not worth re-recording. So since y is less than or equal to over here, I know I'm looking for this area. I got caught up finding the x-intercept. Right, and I'm over here shading where y is less. And there I've got a good sketch. All right, number 5 is x minus y is greater than or equal to 1. So I'm going to just solve for this to get y in terms of x, but maybe this time I will add y to both sides. And I'll say x is greater than or equal to y plus 1. And then to solve for y, I'll subtract 1, and I'll have x minus 1 is greater than or equal to y, which is the same as saying y is less than or equal to x minus 1. And then when I go to graph that, we can x minus 1. Shouldn't be too hard. And since we have less than or equal to, it'll be a solid line. And just graph it like that. That'll be 1. This will also be 1. No, that'll be negative 1. Okay, and where y is less than or equal to, well, that would be down here. The last of these graph problems is negative x is greater than y. And I think I will do the same thing before. I'm going to say that's y is less than negative x. And I can draw, well, y equals negative x would be that line going through the origin. So maybe y less than negative x, I'm going to need a dotted line. Pardon me. And then where y is less is going to be underneath that. All right, now we're going to get into some of the more typical algebra problems. And it's going to say, let f be the linear function given by f of x equals negative 7/4 x plus 2. For what values of x is f of x less than or equal to 0? Okay, well, we have a formula for f of x. We're going to plug it in right there, and I'm going to say negative 7/4 of x plus 2 is less than or equal to 0. And then I'm going to solve for x. So I'm going to start by subtracting 2 from both sides, and I'll say negative 7/4 x is less than or equal to negative 2. And then I will multiply both sides by 4 and divide both sides by negative 7. Okay, and when I multiply both sides of an inequality by a negative number, which I'm about to multiply by negative 1/7, that's going to turn around the direction of my inequality. So that'll be 8 divided by 7. And that's the values of x that make f of x less than or equal to 0. All right, now we've got two functions, and we're interested in when is g of x greater than h of x. Okay, well, I've got a formula for g of x, that's 5 minus 2x, and that needs to be bigger than the formula for h of x, which is going to be 2x plus 3. And I'm going to start by, I guess, adding 2x to both sides. So I will just have 5 over here, and 2x plus 2x is 4x, and then still plus 3. Then I will subtract 3 from both sides. 5 minus 3, that'll be 2 is greater than 4x. Divide both sides by 4, and I will get that 2/4 is greater than x, which is the same as saying x is less than 1/2. All right, now we're going to look at a picture of a graph and determine the inequality that describes it. So this looks like the line y equals, what is the slope here? Okay, I know it's going to be some number of x's minus 4. So it went up by 4 and over by 3 to get to this point. So I know that the slope is 4/3. So I know that the equation of this line is y equals 4/3 x minus 4. But I know they're also shading below the line, so it's going to be less than or equal to, and equal to because the line is solid. Number 10, we're going to look at this graph, and it looks like this is just y equals negative x minus 5. Okay, so if it was just the line, we'd say y equals negative x minus 5, but since we're shaded above, it's going to be greater than, and because the line is dotted, it's not going to be greater than or equal to. All right, now we've got one of these situational problems. So suppose it takes 2 minutes for your teacher to grade an algebra test and 3 minutes to grade a geometry test. Suppose also that your teacher can spend at most 90 minutes grading tests in a day. Okay, I want to just highlight the at most part of that sentence and to just remind you that that means that it's going to be a less than or equal to 90 situation. Okay, so the total amount of time is less than or equal to 90. In fact, I might even write that out. Okay, because of the at most. It's okay to spend 90 minutes grading tests. 91 minutes, not going to be okay. So the total time is going to be equal to 2 minutes per algebra test plus 3 minutes per geometry test. So if x is the number of algebra tests, the total time spent grading algebra is going to be 2x. And then 3y there for 3 minutes for each geometry test. That's the total time, and that needs to be less than or equal to 90. Okay. Number 12 is going to tell you to sketch the graph. And we can do that. Okay, so I think I'm going to I know that if I was to solve this around, I would get this y. I'd subtract 2x, I'd divide by positive 3. I'd never reverse the direction of the inequality. So I know it's going to be y is less than or equal to. So and I also know that, we're not interested in grading negative numbers of algebra geometry tests, so I'm only going to graph the first quadrant. And I will start over here by saying, all right, let's find the x and y intercepts. So the x-intercept, that's where y equals 0. And I'll plug in y equals 0, and I'll say that's 2x equals 90, and okay, that's going to be x equals 45. All right. I'll put 45 there. Right, to find the y-intercept, I'll set x equal to 0, plug it into the equation, I'll be left with 3y equals 90, and then I'll know, okay, y needs to equal 30, because 30 is going to be the number I can multiply by 3 to get 90. Okay, and that's not going to go up nearly as far, that will just go up to there, and then I will connect them with a line, okay, and it's going to be solid because it was less than or equal to. And then the solution region is going to be in here. I'll try to clear this in without, it'll be there. Okay, that's the graph of the solution region for the inequality. Okay, I did not look ahead at this problem set, and I didn't realize that the next two questions were going to be talking about the x-intercept and the y-intercept and what they mean. So I think I'll just leave that there. Maybe zoom out a little bit. Give myself some room to write about meaning of this first x-intercept. Okay, I already calculated it. It's x equals 45. And what that means is that if I decided to grade only algebra tests, right? Y equals 0, that's 0 geometry tests. If I decided to grade only algebra tests, I could grade up to 45 in a day. So I would say if I'm not grading geometry. Okay, and then the meaning of the y-intercept, well, that's going to be the exact opposite, right? I could grade up to 30 geometry tests in one day if I'm not grading any algebra. But you didn't need to sit and watch me write that. Okay, I think that's all of the problems on this set. So that'll be it. Thanks for watching.